transverse section of the pons at the level of the trigeminal nerve and at the level below the trigeminal nerve, closer to the pontomedullary junction. The basilar part of either sections are the same. That means whatever you are going to find in the basilar part of the upper part, you're also going to find the same at the basilar part of the lower part. So I'm not going to discuss all those structures that I've already discussed in the upper pons. But you should also see that we have all this core-to-core spinal and core-to-core nuclear fibers or tract. Are you clear? Those that are descending from the cerebral peduncles. You can also see the pontine nuclei with this interspersed corticospinal and corticonuclear tracts. Then you have all this, middle cerebellar peduncle, taking origin from all these pontine nuclei of the opposite side. So you have this pontocerebellar fibers coming from this, pontine nuclei going into the cerebellum, so that they form this our middle cerebellar peduncles. Similarly, at the group here, you can also see, this basilar artery. So it's the same, no matter what level you take, all the sections are going to be the same. What only differs between the two sections is the tegmentum. The content of the tegmentum in the upper part and that of the lower part differs. So we said the contents of this upper part of the pons differ from the contents of the tegmentum in the lower part. So now let us see the differences between the two contents. In the tegmental portion of the pons at the upper part, you are going to see all these three, tracts in the middle line. Our medial longitudinal fasciculus, posterior most, you have your tactospinal tract, a rubrospinal tract. So also here, you can also see it in the lower part. Similarly, you are going to see that just posterior to the basilar part of the pons within the tegmentum, you are going to see this lemnisci. But the lemnisci that are here in the upper part, they differ from the lemnisci that are found here. Difference in the sense that all are seen here, but some are missing here. Ideally, you are supposed to see this arrangement. Medial lemniscus from the medial side, trigeminal lemniscus from next to it, spinal lemniscus next to it, and the lateral lemniscus, the most lateral. Are you clear? So when you come to the lemnisci in the lower part, of course, the medial lemniscus still the same here because it's already formed from below. You get my point? Because it started from those our cunate nuclei and gracile nuclei and what have you, crossing to the opposite side. Here you can see the trigeminal lemniscus here. But here, ideally, you're supposed to see it here, but it's not here. You cannot see. Why? Because it is not formed. Are you clear? So you cannot see the trigeminal lemniscus at the lower part. Are you clear? Reason because, if you can remember, we said trigeminal nerve has how many nuclei? 3. We have the spinal nucleus. We have the pontine nucleus, which we call the principal pontine nucleus, sensory nucleus of the trigeminal nerve. We call it what? Principal pontine sensory nucleus of the trigeminal nerve. And then we have the mesencephalic nucleus. So we have 3. Are you clear? So at this lower level, since the trigeminal nerve, we said it begins from where? From the midpoint. Are you clear? So this pontine nucleus, you get my point. It begins around this side. You get it, the tract, it begins from here up. So any section below it, that lemniscus is not formed. But it's only the tract that is going up to meet the pontine nucleus. You get it, before it finally meets the mesencephalic nucleus and then ascend up. Are you clear? So now the trigeminal lemniscus cannot be seen at the lower section. So that arrangement, that is why I cleaned this one here. Are you clear? So what we are going to see here, you are going to see the medial lemniscus, you are going to see the spinal lemniscus with the spinal nucleus of the trigeminal nerve coming from the medulla oblongata. Are you clear? And the spinal cord going up with a tract forming here now. So by the time it reaches up, it forms, this is the principal pontine nucleus that we're talking about. And so by the time this fibrous tract reaches here now, so this tract is already formed, then it ascends up. Are you clear? So that is why you cannot see the trigeminal lemniscus here. And so you can only see the medial lemniscus and the spinal lemniscus. Are you clear? So you, on the medial, on the lateral to this, you are going to see the spinal nucleus of the trigeminal nerve as well as the tract. This is the spinal nucleus, not the principal pontine nucleus, the one we are talking here. Are you clear? Good. So again, you are not going to see this lateral lemniscus. Why? Because the lateral lemniscus is formed by the dorsal and ventral cochlear nuclei of the vestibulocochlear, the cochlear component of the vestibulocochlear nerve. Are you clear? And these two nuclei, one lies ventral to the inferior cerebellar peduncle, which can be seen at this section. If you can remember previously in the upper section, we said we can see the superior cerebellar peduncle as it is descending from the midbrain when it is way towards the cerebellum. So also in the tegmentum, on the lateral side of the tegmentum or the lower part, the inferior cerebellar peduncle, as it is connecting the medulla oblongata from below, some fibers, they just enter into the lower part of the pons. And that is why when you now take the lower portion, you will see this inferior cerebellar peduncle section. Are you clear? So these two cochlear nuclei, that is the dorsal and the ventral cochlear nuclei of this vestibulocochlear nerve, there is cranial nerve, so they lie in relation to the inferior cerebellar peduncle. Are you clear? So it is this fibers here of the dorsal and the ventral cochlear nuclei that they come, all the axons, they come and crisscross to the opposite side like this. Are you clear? So also these fibers from this side also, they now come and crisscross until they now reach the opposite side. Are you clear? So that they form this trapezoid body in the midline. Are you clear? So this trapezoid body, you can see it is formed at the lower part of the pons, but it's not seen in the upper part because the nuclei are not there. Are you clear? So the trapezoid body is only seen at the lower portion where the cochlear nuclei are located. So that by the time the fibers crisscross, they now form this trapezoid body in the midline. And so as they go towards the opposite side, as they form the tract, if this come to this side, these axons, as they come towards this side, they ascend up. They now ascend up, like this. They go up as they go into the upper part of the pons and form this lateral lemniscus. So also from this side, as they come toward this side, these axons, they come and ascend up, until they go into the upper part of the pons so that they form the tract, the lateral lemniscus. Are you clear? So now we've seen how the lateral lemnisci are formed from crisscrossing of these fibers from the dorsal and the ventral cochlear nuclei. So that means here you will not see the lateral lemniscus because it is passing above, so it's not formed at the lower part until it ascends up towards the upper part, and then you can see the lateral lemniscus on this side. Are you clear? So you can only see how many lemnisci here? 2. You will see the medial lemniscus and the spinal lemniscus. So that is what you are going to see. As I told you before, the midline structures this medial longitudinal fasciculus, which we said is responsible for, connecting those cranial nerves that I've made mention before. What are the cranial nerves? There are 3 to 4. We made mention about the oculomotor nerve, the trochlear nerve, the abducens nerve, plus the vestibulocochlear nerve. You get my point? So vestibulocochlear nerve is also connected with this medial longitudinal fasciculus. I've already told you the function before that it is responsible for integrating eye and head movement. All our eyes and our head and neck movement, when we now see a visual stimulus, the movements are integrated together in form of reflex. Are you clear? So that's the function of this medial longitudinal fasciculus together with the tacto-spinal tract, because they are interrelated. So their own function is virtually similar. Are you clear? Because tacto-spinal tract, you know, it's also responsible for this, our visual and auditory reflexes that we have discussed before. So again, by the side of this midline structures, just at the posterior aspect anterior aspect to this, because this is fourth ventricle at the back of the pons, this is the fourth ventricle here. So within the tegmentum at the posterior, at the anterior aspect, posterior aspect of it here, you have what we call the abducens nucleus. That is the sixth cranial nerve nucleus. So our abducens nucleus, which is this one, lies at the anterior aspect of the posterior part of the tegmentum towards the midline. Are you clear? So this abducens nucleus, it is on nerve fibers, you know, comes and pass anteriorly like this. You know, so they pass forward until they pass just within the basilar portion of the pons, so that they lie at that pontomedullary junction that we discussed before. Because we said that the abducens nerve is the first nerve to exit at that junction, closer to the midline, and then followed by the seventh cranial nerve. We already said that, right? And then the last one is what? The vestibulocochlear nerve. These are the three nerves that exit. This is the sixth, then the seventh, then the eighth cranial nerve, which we discussed its own nuclei here. So these are the vestibulocochlear nerves here. So they come and exit here. Are you clear? So we have the sixth nerve. Its own nucleus is, we said it is at the posterior part of the tegmentum, closer to the midline. So the fibers, the axons, they pass forward at the pontomedullary junction, and then the nerve exits like that. It goes into the eye. Then followed by the facial nerve. The facial nerve exits from the tegmentum of the lower part of the pons by 4 nuclei. Are you clear? What are these 4 nuclei? Number 1, we have the motor nucleus of the facial nerve. This motor nucleus of the facial nerve lies anterolateral to the nucleus of the abducens nerve. We said what? It lies anterolateral to the nucleus of the abducens nerve. And so this nucleus of the facial nerve is the motor nucleus of the facial nerve. So the axons of these neurons, they now pass medially, then backward, until it now surrounds or rounds around the abducens nucleus. So the nerve fiber exits out of the pons. Are you clear? So it now forms like a round fibers around the nucleus of the abducens. And these fibers as they surround the backside of the nucleus of the abducens nerve, they form a swelling that is shown, or that can be seen when you look at the back aspect of the pons. You get it? And this swelling at the back part of the lower part of the pons is what we call facial colliculus. So the facial colliculus is formed mainly by the abducens nucleus as well as the surrounding axons of the motor nucleus of the facial nerve. Are you clear? So now this exists like that. So we have now seen that the motor nucleus of the facial nerve surrounds the abducens nerve. Similarly, anterolateral to the motor nucleus of the facial nerve. Remember, I said that the motor nucleus of the facial nerve lies anterolateral to the abducens nucleus. Are you clear? So now the same thing. There is one nucleus, what we call nucleus of tractus solitarius. That one lies also anterolateral to the motor nucleus of the facial nerve. Are you clear? And again, there is another nucleus, what we call superior celebratory nucleus. That one lies anteromedial to the motor nucleus of the facial nerve. Are you clear? So you have two nuclei lying anterior to the motor nucleus of the facial nerve. One lies lateral, the other one lies medial. But all of them, they are all anterior. That is why we call the other one anterolateral, the other one is anteromedial. So all the axons of these two nuclei, one from the nucleus of tractus solitarius, the axons there, they join the motor fibers of the facial nerve. Similarly, the fibers, axons, the axonal fibers of the superior celebratory nucleus, they also join together with that of the motor fibers of the facial nerve. Are you clear? So that they now form a bundle. Similarly, there are some axons of neurons coming from the trigeminal nerve nucleus. We have trigeminal nerve nucleus and tract from this side before the trigeminal lamellus is found here. Are you clear? So some of these axons, they also come here and join the facial nerve. You get my point? What are the functions of all these four nuclei in relation to the facial nerve? You see, the motor nucleus, as I told you before, all these motor nuclei are responsible for the motor movement of the areas where they supply. If you now take, for example, the abducens nucleus, this abducens nucleus supplies one of the muscles of the eye. Are you clear? What we call the lateral rectus. So the lateral rectus, is supplied by this, and it is the only muscle that is being supplied by the abducens nerve. Are you clear? So, and its own function, is just to abduct the eye towards the lateral side. That is what we call lateral rotation of. For example, if you want to look at by your side, are you clear? That is the function of this nucleus. But for the facial nerve, its own motor nucleus is responsible for the supply of all the facial muscle of expression. You get my point? There are several of these muscles of facial expression, So the motor nucleus is responsible for the supply of this. When you do the head and neck, you are going to be told all the different varieties of the muscles of the facial expression, to smile, to laugh, to cry, to open mouth, to close, something like that. All this expression of, although actually closing and opening of the mouth is not part of the expression. That is done by a particular group of muscles, the pterygoid muscles and what have you. They are not part of the muscles of facial expression. Are you clear? So I said that the muscle, the motor nucleus of the facial nerve, is responsible for the supply of all the muscles of facial expression. The nucleus of the tractus solitarius, you get it? This nucleus is responsible for carrying taste sensation. If you can remember, we discussed about the taste. Anterior to third of the tongue, the mucosa over there, the taste buds that are over there, the sensation is being carried, to this nucleus. Are you clear? So taste sensation is being carried through this, from the anterior to third of the tongue to this nucleus. Are you clear? So that this nucleus of tractus solitarius is sensory. Are you clear? So it's carrying sensory information from the anterior to third of the tongue for taste, and then it passes through the facial nerve. Are you all clear? Good. The other one, this superior celebratory nucleus is responsible for the supply of, secretions of the salivary glands, especially, not only salivary glands, we have the lacrimal gland in the eye. This nucleus also carries information, from there to this nucleus. So also the palatine glands in the oral cavity. We have palate. When you open your mouth, the roof of the mouth, that is where your palate is. You get it? So along the palate, there are some salivary glands. And so the salivary glands are responsible, this nucleus is responsible for the secretions of all these glands. So also in the nose, inside our nose, we have some mucus, inside our nostrils. So, and the secretion of this mucus is as a result of this nucleus. So all these secretions, lacrimal gland, when you cry, you see tears. When you are having catarrh, you see excessive secretion of mucus from the nose. when you see very nice food, you start bringing out some saliva, gathering inside your mouth. All this as a result of this superior salivatory nucleus. So all the salivary glands and some of the mucous gland, the lacrimal gland, the nasal mucosa, the palatine glands, salivary glands in the palate, and also the sublingual and submandibular glands. All these are, salivary glands that have been, under the control of this, superior salivatory nucleus. The only gland that is not part of the fibers coming into this is the parotid gland, which we'll discuss later on. So all those glands, it is this gland that is responsible for their own control for their secretions. That is secretion of the lacrimal gland, secretion of the palatine glands, sublingual, submandibular, and also the nasal mucosal glands and what have you. So we have seen that there are 4 different nuclei joining the axons, joining together to form the facial nerve. So this tract, this nucleus of the trigeminal nerve, as it connects with the facial nerve, its own major function is to carry sensation from the external ear and the middle ear so that it takes it through. I'm sure some of you now, if you eat food, very nice, very soon you will see your ear is aching. It's making some very nice sensation, tingling sensation. If the food is very nice and tasty, are you clear? It is through this pathway. Are you clear? So that you start rubbing your ear like this if the food is sweet. Are you clear? That is exactly the reason why you have that. So now we've seen the facial nerve and all the 4 nuclei that we have seen in the tegmental part. So the other nuclei of importance or of relevance is this vestibular nuclei complex. You get my point? This vestibular nuclei complex is made up of about 4 groups of nuclei. These vestibular nuclei, they are about 4. We have one lying above, like this. You have one on the medial side. You have another one on the lateral side, and then you have the other one below. So it's just like 4 groups of nuclei in one, forming a complex. So you have superior, you have inferior, are you clear? Then you have medial, then you have lateral. Are you clear? So this vestibular nuclear complex, they are 4 in number. But one thing is that you can only see 3 of these nuclei in the lower part of the pons. The inferior one is just below, around that upper part of the medulla. Are you clear? So at that junction, before all the fibers, the axons from the superior, from the lateral, from the medial, from the inferior, from lower part, around that junction, they all combine together to exit by the side of the facial nerve. Are you clear? So that at the end of the day, we have this our 6th cranial. This is our 6th cranial nerve here, the 6th here. Then you have our 7th, which is here, and then this is our 8th. And that is what we have already made mention when we were discussing about the ponto-medullary junction. So this is the way they exit from the lower pons. So now we've seen the lower part of the pons. The next, discussion or lecture should be about the upper part of the medulla oblongata. And then we now take a section again at the lower part of the medulla oblongata. But by so doing, we should be able to finish the brainstem. And after that, I will now discuss with you the back aspect of the brainstem. Because if you can remember, the first lecture I did is about the ventral aspect of the brainstem. So deliberately, I refuse to discuss the back aspect of the brainstem because we have not discussed these sections. After that, we'll now discuss the back side of the midbrain. That will help you understand the actual structures of the present and the posterior aspect of the midbrain. So we have a break.